Alright guys, so today we're going to be talking about nitrogen alkylation. And essentially what this is when we have ammonia, which is NH3, we're going to react it with a molecule that has a methyl group, which is CH3, bonded to a halogen, and what that's going to get us is a tertiary amine. So that means that this nitrogen here is bonded to 3 carbons. So there's a couple of halogens that we can use in this reaction to make it work. So we could use chlorine, or we could use bromine. Now, just choosing randomly, we'll go with bromine. So here's the mechanism as follows. So first, let's draw out our ammonia, NH3 right here, and it has a lone pair. And we're going to react it with our molecule right here, which is the bromine and the CH3. So what's going to happen is this lone pair is going to grab onto our carbon, and the bond is going to break, putting those electrons onto our bromine. So now what we have is a nitrogen that has our hydrogens still intact, but now we have a nitrogen bonded to carbon, and therefore it has a positive charge because it doesn't have a lone pair anymore to stabilize it. So what we'll do now is we will bring in another NH3. There's a lone pair, and what it's going to do is it's going to take a hydrogen and move those electrons onto the nitrogen. Now the reason why we use NH3 instead of the bromine we broke off is because NH3 is a way better base, and therefore it's going to feel more compelled to take the hydrogen than the bromine. So now what we do is we have our hydrogens here and our CH3, and we will bring in another equivalent of that first molecule we saw with our bromine and our CH3, and it's going to do the exact same thing that we saw before. So this lone pair is going to grab the carbon, and that bond's going to break and move those electrons onto the bromine. So what we get, I'll draw it down here, is not just one methyl group, but 2. And therefore it has a positive charge because there's no lone pair. And once again, NH3 is going to come in with its lone pair, and it's going to grab one of those hydrogens, moving those electrons onto the nitrogen. So what we get here is a secondary amine, right? Because we have 2 carbons on our molecule now. So now to get to a tertiary amine, we will do a reaction one more time, or the steps technically. And the nitrogen has a lone pair. It's going to grab the carbon, that bond's going to break, moving the electrons onto the bromine. And what we get is our nitrogen here, with only 1 hydrogen left over, has a positive charge. And we will bring in another NH3 with a lone pair. It's going to grab that hydrogen and move those electrons onto the nitrogen. So what we end up with is our tertiary amine. Now, you could probably do this reaction again since there's another lone pair, but that's not recommended because then you would end up with a quaternary amine, and therefore the nitrogen has a positive charge. But since nitrogen is really electronegative and favors a negative charge, this would not be a stable molecule. So therefore we end it as a tertiary amine. So this is the complete reaction and mechanism for nitrogen alkylation. Have fun with it. I hope this helps, and I'll see you guys in the next video.